Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the center of buoyancy and meta center, and also the stability of cargo ships. So let us first of all discuss the center of buoyancy. So center of buoyancy is the center of gravity of the liquid displaced by the immersed solid. So let us suppose a situation that this is a cylinder which is partially immersed into the liquid and its h by 2 height is immersed in the liquid. So you can imagine that this cylinder has displaced this shape of liquid which is also cylindrical, but the height of the liquid cylinder which is displaced by this cylinder is h by 2 and area is A. So we can say that the center of gravity of the liquid cylinder which is displaced by this solid cylinder is at a height of h by 4 from the base of the cylinder. So we can say that the liquid displaced by this cylinder is this one, and the center of gravity of that liquid is this one. So this is the center of buoyancy, and center of gravity of the solid is this. So center of buoyancy is a point where we can assume that the complete buoyancy force is concentrated. So this is the center of buoyancy, and we can also say that center of buoyancy is the geometrical center or centroid of the immersed part of the solid. So if this immersed part is this half cylinder, then we can say that center of buoyancy will be the geometrical center of this half cylinder. Now, if the shape of the solid is conical and it is completely immersed. So first of all, let us see that what will happen when we will continuously immerse this cylinder deep inside the liquid. So when we will continuously immerse this cylinder inside the liquid, the center of gravity will remain at its place, but the center of buoyancy will move towards center of gravity. And as soon as the cylinder is completely immersed in the liquid, then the center of gravity and center of buoyancy will be the same points. So if this cone is immersed in the cylinder, then we can say that the liquid displaced by this cone is also conical of the same dimensions, and hence the center of gravity of that liquid is this point, as well as this is the center of gravity of the cone also. So we can say that the center of buoyancy and the center of gravity of the cone is same point, which is h by 4 from the base of the cone. But this is the case in the case of uniform mass distribution. And we can also conclude that in uniform mass distribution, the center of gravity cannot lie below the center of buoyancy. What maximum can happen is the fact that these 2 points are the same points, but this cannot happen that center of gravity goes below the center of buoyancy in uniform mass distribution. But when the mass distribution is non-uniform, like that, like you can see in this case. So in this case, this cylinder has non-uniform density, and the lower half of the cylinder is heavy and the upper half of the cylinder is light. So the center of gravity of the cylinder is at a height of h by 4 from the base of the cylinder, while when we will completely immerse this cylinder inside the liquid, then the amount of liquid or the volume of liquid displaced by this cylinder will be same as the total volume of the cylinder. And as the fact that liquid has a constant and independent invariable density, so we can say that the center of gravity of the liquid displaced will be the geometrical center of the cylinder, which is this point, while due to the non-uniform mass distribution, the center of gravity of this solid cylinder will be at this point. So in this case, the center of gravity is below the center of buoyancy. But this happens only when the mass distribution is non-uniform. Now let us talk about another important point, which is also called as meta center, and the stability of the floating object. So let us imagine that this is a block or cylindrical block which is partially floating in the liquid, and the center of buoyancy is below the center of gravity. Now the shape of liquid displaced by this block is this one, and when we will tilt this block by some angle, then the shape of liquid displaced will be like that. So you can see that the shape of liquid displaced has changed, and therefore center of buoyancy will be different point, and this is the new center of buoyancy. Now just imagine this line which contains center of gravity and center of buoyancy initially. Now the center of buoyancy will be a different point, and the buoyancy vector will be acting like that. So this point where buoyancy vector cuts this initial line, this line is called as meta center. So this is the meta center, and you can see that as the meta center is above the center of gravity, so there is a torque which is created by the buoyancy about center of mass, which is anti-clockwise torque in this case. So this torque is turning this floating object back to its initial position, and hence this is restoring torque, because this torque is restoring the object in the initial position. But when this cone is inverted in the liquid, and it is immersed in the liquid partially, so the center of buoyancy will be this point and center of gravity will be this point. And in this case, if I tilt this cone by a slight angle, so you can see that the displaced liquid will be of this shape, and the center of buoyancy will be this point, will be a different point, and the buoyancy vector is cutting this line at this point, which is also called as meta center, and in this case the meta center is below the center of gravity. And due to the fact that meta center is below the center of gravity, the torque created by the buoyancy about center of mass is clockwise, which is the toppling torque, and this torque will topple this cone, and this cone will not regain its initial position. So we can say that when meta center is above the center of gravity, that position is stable equilibrium position, and when the meta center is below the center of gravity, that position is unstable equilibrium position. And the same is the concept behind the large ships. You have noticed that the large ships has the heaviest portion, which is the engine, situated in the deck of the ship, and this is due to the fact that to keep the ship floating stably in the waves, it is required that center of gravity should be at the lowest point which is possible. So by keeping the engine in the deck, the center of gravity is lowered to a large extent, and due to that, when the ship tilts, then the meta center occurs above the center of gravity, due to which the torque created by the buoyancy about the center of gravity is restoring torque, and it restores the ship into back to its initial floating position. But when the center in the cargo ships, you have seen that there are blocks which are staked on the ship like that. So due to this staked blocks, the center of gravity in the cargo ships go up, and therefore the meta center comes below the center of gravity, and due to this fact, the buoyancy creates a torque about center of gravity, which is clockwise torque, and which topples the ship, and ship gets overturned. So this was the factor behind the Titanic, that it was claimed that Titanic could not sink ever, but we all know that why it sank, because it had a collision with the iceberg, and due to that damage, liquid was getting inside the ship, and it sank due to that liquid filled in it. And the engine of the Titanic was in the deck, and hence it was claimed that center of gravity of the Titanic is so at the lowest position, so that it will get restored to the initial position after turning by a large angle also. But this was just one dimension of the ship. The accident occurred, and it got sinked. So this was it in this video, and in the next video we'll be discussing the numerical problems on buoyancy. Thank you.